welcome everyone. Thank you very much for dialing in. Now it's 3 p.m. and supposedly we will be starting shortly. Okay, but now we still have people registering in and dialing in. So if you guys don't mind, we will begin very shortly, probably in 3 minutes. Okay, so thank you very much for dialing in early to the rest of you. And please do grab a cup of coffee or tea and have it by your side because today's session is expected to last around 2 hours. All right, so from 3 until 5. Our second guest speaker from Vitrex, Gary Leong. He is the Director of Industry 4.0 and Ecosystem Development from Vitrex. So he will be discussing or sharing on embarking the predictive journey with AI machine learning. So here's a speaker profile of Gary. So he is passionate in assisting or transforming Malaysia's manufacturing sector into Industry 4.0 ready and to be competitive in the worldwide stage. So he is very passionate in Industry 4.0 development, all right, in Vitrex, and he is tasked to expand and share V1 and in-house develop I4.0 manufacturing intelligence software in the manufacturing sector. Okay, so he is a graduate in UK, and Mr. Gary has 20 plus years or 2 decades of working experience in international sales and marketing, product development, product marketing, and team development. And Gary's key mantra will be, in the era of Industry 4.0, digital transformation journey can begin with you. All right, so Gary, I hope you are ready for your session. So the floor is all yours.
Good afternoon, everyone and fellow attendees to this webinar organized by SHRDC, and also thank you for the organizers for kindly inviting me. My name is Gary. I'm from Vitrex Technologies in Penang. We are a local company based out of Penang. Of course, we provide our solutions to the global. So this is a picture of our company in Batu Kawan in Malaysia. So let me just do some introduction and I'll share with you more. So today's topic I'm going to share about is embarking the predictive journey with AI machine learning. So I'm going to share more what is machine learning a little bit, and then what we're going to use for, especially in Vitrex, and also how we're going to help some of it, our customers and also our suppliers, in terms of making their machines smarter. Okay, so as I mentioned, we are in Penang. This is our campus 2.0, and we have a new purpose in 2021 to contribute to the advancement of society and well-being of humankind through compassionate innovation. And of course, we aspire, and our vision is to be a world's most trusted technology company. Okay, in terms of some financial background and contributors, we are about 800 plus, almost close to 900 people worldwide. Most of them are actually in Penang, Malaysia. And then we are a public listed company in Bursa, Malaysia. And through our journey, actually, we started about 20 years ago. Last year was 20th anniversary. So we are short 21 years. We are now in Campus 2.0, and we just had our groundbreaking for Campus 3, which is beside us. So the journey is so exciting. The journey is accelerating, and of course, it's promising as well. So what we do is that we are in the mostly 91% are in the electronics field, whereby we build our machines with a lot of vision modules, automation, and then in the sector of semiconductor, of course, as well in the electronics assembly, that's where most of my career was in. And then we also venture into machines for the automotive inspection. Pharmaceutical precision farming is our latest adventure, and also in PV. All these are in automation as well as vision inspection. So you can go to our website, vitrex.com, to find out more what we do with our own brand, and of course, of sales and services throughout worldwide. A little bit about me. Okay, I love a lot of things. I love to read, and then I love to do sports, especially like rock climbing. And then with COVID hit Malaysia 2 years ago, we can't go anywhere. Now traveling is one of the top agenda to travel and to speak in front of the stage again. But I'm of course excited to do more in a webinar because it's so easy, and then to reach out to the public and also to the the VAS is easier, right? But what I'm not, I'd like to share with you that I'm not an AI engineer. I am also not a programmer. Okay, so if you ask, oh, if I'm not a programmer, not an AI engineer, why am I talking about AI over here? So let me just go into that. So the whole agenda I'm going to share with you about close to about 40 minutes is about all this. So I'm going to share a little bit about what is before AI, and then our journey from predictive to preventive to predictive, and then from predictive to prescriptive. So that's the next level of where we are going to. And of course, last but not least, we're going to talk about the lessons we have learned, that so that with you, and if you are embarking together with us, that you can use some of these cases, and so that you don't have to fall into some of the traps that is happening while embarking on AI. Okay, and of course, for sure, if you have any questions and answers, please feel free to put in the chat box. And then if you like or don't like it, put some of the emojis at the Zoom. So that's the fun thing of Zoom over here. So what's the digital smart factory journey in Vitrex? Okay, so in most of the companies, there's always one first step: connect to collect the data. So that is always the first step, because if you have a machine, you have a process, you need to get the data connected. You need to get the machines connected so you can collect the data. So you can put in IoT, you can use different protocols to connect to it so that you collect the data either through a Fog server or you can direct it to the cloud. And after that, you can visualize it in different patterns, different charts, different dashboards, whether it's a facets, whether it's a pie chart, whether it's a spider web, and so many radial charts and so many other charts that is best represent your data. Because very much important is that you're able to visualize your data and find the insightful towards your data. And the next is that you can go to AI, you can go to machine learning. And from there, you find out what is the analytics for getting the insights towards the areas of your visualizations, and find a business process stream, especially with AI. Next, after that, is where the digital twin comes in. You can infuse it with cognitive. And one areas that you can also come into it is the new business model. I'll come into that later on. Okay, so just a quick one. I think I'm not going to go deep. Machine learning is part of a subset of AI, and deep learning is part of a subset of machine learning. So all these are available information on YouTube, on internet, where just now my co-speaker, Mr. David Uy, he talks more on the deep learning. Okay, and today I'll go slightly bigger on terms of the machine learning itself. Okay, so where can AI dealt with as well as help in terms of the manufacturing? There are, of course, there are more, but I'm just putting into 5 key areas in terms of how AI, in terms of manufacturing. First, you can detect defects through the production process, especially in terms of using optical inspection or automated visual inspection, where unstructured data such as images, and then you can use that to do best use deep learning of that. And then on the second one, you deploy preventive or even predictive maintenance to reduce downtime and improve processes. So these are a lot of structured data, and you can use that to predict and even prevent some of the areas to reduce the downtime, especially breakdown of parts, especially of critical parts as well. So this is where I'm going to focus as well deeper. Other areas like in terms of response to changes, it could be supply chain, GIT that involves connectivity to MES, advanced production planning, and so on and so forth. Others connecting to robots, and the last but not least will be the next level towards Industry 4, could be Industry 5, or some call it the lot size 1. So there will be a lot of areas of reducing costs, single run goods, and enable better customization. So this is where many areas that will expand beyond the AI side. Okay, so how do we take AI in Vitrex so that we can expand across many business units and also many of our engineers able to use it? Okay, one, you can choose a programmer way whereby hire a programmer, write the Python codes, and then you can do all your analysis. This is very good because this will enable a lot of customization. However, in V1, we enable what we have done on the programming side, and we provide it into a less coding method. We put it in the workflow. So I'll show you how we do that in a short while, so that this enable people like me without a programming background able to do some AI machine learning. Okay, so what we did is that we combined 15 different algorithms, 8 in the supervised classification algorithms, 6 in the regression algorithms, and 1 in the unsupervised clustering algorithm. So all these are being done in the library so that the users can just click and choose and then find out which algorithm works best for them. Okay, let me just share with you how I will do it in terms of the a slide demo so that you can understand. Can you still see my screen?
Yep.
Okay. Okay, I log into. Okay, so I will. Okay, I will create a plan. So let's say, for example, I put SHRDC. I do a classification training, a template for classifying training. Okay, so in this template, the whole process of a training a model is now enabled. So so it's easier for me. I don't have to write all in sequence. I click the design. Then over here, there is input, there's process, machine learning models, and also the action. So the first step, I will just put in the data source. For example, if I create one data source already, and then I click on the data source. Okay, so this is one of the data source which includes 1,000 overlines, 1,600 overlines. Okay, and then okay, just to ensure that everything is done. Yep, I include everything. Okay, then after that, I just double check. Okay, if there's any replace missing or not 0 to 0. Just double check. Okay, I think these are strings are okay without doing anything. So I can do a split data. Let's say, for example, if I put 70% or 30%, 70% as a training, 30% as a validation to check what is the accuracy from that. Then training, okay. So because here is a structured data, I'll remove deep learning because otherwise it'll take a lot of time. And then what are input variables? I move everything in my X bar into the input variables. And then after that, I take a solution as my output. Okay, a solution as output. So I can see over here, so for example, certain things that I do not need, I just remove it. And then maybe here I don't remove it. And also there are also other things I can remove it so that it makes it better in terms of okay, living area as well. I don't need that. Okay, then click. Then okay, training done. Then I run the model. As the model is running, so you're able to tell that, okay, this is pass, there's a green here. If it's an error, it will be an X with a red color. Then it runs, now it's on the training side. So it's run about seven different algorithms all at the same time to find out what is the best. Okay, so right now it's done. Okay, now I will check. Okay, so in terms of the training side, I can see that it was 100% in terms of the decision tree and also the random forest. Runtime means the time to compute in terms of seconds. This is 2 seconds. I think these are okay. So between the decision tree and random forest is the highest accuracy. If I go to performance, see that decision tree is only at 60% and the random forest is 68%. It's not very good, but it's okay. You know, we can run better. Okay, and this is the runtime. If there are certain areas that requires runtime to be very much lower, then this becomes a very important areas. Then if let's say this is not good enough, I can do a split the data even higher. Let's say 85%. Okay, and then I can run again. Okay, so it's done. So I double check in terms of the validation model. Now it's higher. Just now was below 70. Now it's slightly higher in terms of 72. Another one is 66. Round time wise, okay, this takes slightly longer, about 16 milliseconds, and this is decision tree. So you can actually, if the time is okay, you can choose a random forest over here. Then after that, I save the model. Okay, I go back. Then let's say I click another inferencing. Let's say SHRDC inference. Okay, I add. Then the template comes out, and I retrieve the. I click design. Then I retrieve the model. This is the model. Just now I said test the training over here. Done. Okay, just double check. Yeah, this is the 7 algorithms I choose. And then after that, I can just run again. So I run again, then the data source, I click back the same data source that I choose. Or a different one if you have a different data source coming in that goes to training. And then after that, you run it, you go to this prediction. Okay, so just quick ones. That's it. 5 minutes. I can just show you a different model. So I can share with you how I just did, a 5 minutes demo on machine learning, using machine learning on total 7 different machine learning algorithms in under 5 minutes. So this is applicable to a lot of machine engineers, even in a factory which is not very well trained in terms of AI. So we want to make it useful. We want to make it easier for customers. So, okay, so on the next topic, I will talk about from preventive to predictive. Of course, if you have any questions and answers, please put in the chat box. Likes or don't likes, you can put in with the emojis. Okay, so we build the machines. This is one of the machines that we built over here, and then it's a vision inspection where the calibration is very important because you have to make sure that the things are accurate. So what we do is that we have this gray card, calibration card that is fixed mounted onto the machine, and every now and then they need to automate the camera to sort of take the pictures of the gray card level, and then to map out what is the gray scale. Okay, and then from there you will check and see other hardwares, whether it's or with adjustment, is it how many times is it overdue. All these are preventive maintenance. And if let's say certain things are over limit, then it will prompt us to, or the engineers to do maintenance. And of course, if there's no overdue, then it will not flag. So all these are in preventive maintenance. So these are very simple, easy way to make your machine smarter and inform the engineer what are the things that needs to do. So, okay, and then after that, another machine I'm sharing in terms of Xray. So we put in different IoT sensors like temperature sensors, fan sensors on the machine, of course, pressure, and also the digital power meters on it. So what we do is to monitor the two of the most expensive parts within the Xray machine. So we don't have to do everything. So because we know that what are the areas, the spare parts or the parts itself that is most critical that will happen if we don't monitor it. Okay. For example, so we do a hardware monitoring, as what I shared with you just now, and the areas of in the areas as the temperature near to the tube, and also the safety shield, and the temperature and also vibration and the pressure near to the tube, because the tube is one of the most expensive item within the whole machine. Why do I say that? This tube costs, as list price, 65,000 US dollars. So it's expensive as a BMW, maybe 3 Series, 5 Series, right? Okay, so you don't want this to happen. And then for us as well, we need to minimize our asset of putting the consignment of Xray tubes so that we are able to keep our inventory low. So of course, one of the areas is that to change the hard copy maintenance record into digital maintenance record. For example, 6 months e-record, last calibration, how's the cathode level, number of hours that is Xray is on, or even the number of hours the machine is on. Okay, so all these are part of puzzle process of digitalization and converting hard copy materials into not scan but into digital records. So these digital records will go into database. So one of the use cases that we are testing upon is that if the triggers from the Xray tube, especially the temperatures and the spikes, all these things are okay, then it tells you that the level of trigger logs and the last preventive maintenance predictive, even the preventive maintenance done. So it will be able to tell you what is the machine learning prediction, how many hours can still last for that particular tube. However, if the triggers from various sensors spikes up critical times, like for example, if a person keep on coughing many times, you know that this person has some symptoms is happening. So for machines, the same thing, that it will sort of cough, and then the machine learning will learn from that what is the prediction. Will it a lifetime sort of lower because of certain symptoms? Okay, and from that we monitor from the triggering that happens at that particular time, how many times it sort of cough, or temperature spike above, or the abnormal vibration, or even sound. And that triggers, it could be an email, and triggers the person to do some checking. And this is what we say the Amber Alert. And the whole aim is to convert an unplanned downtime to a planned downtime. Okay, so I've shared with you what we did is on the Vitrex machine. So if you ask me, how do we do on other machines? Because it's easier for us to do on our own machines, but we also embark on other machines to help out our suppliers, especially in the CNC metal fabrication market. Okay, so of course we have done many visualization and also connecting to the machines throughout our journey of this analytics intelligence solutions. But I'm going to share about more towards how do we do that in terms of AI and also the predictive area. So what we did in terms of the connect on this machine, this CNC machine is not a Vitrex product. Okay, so what we did is that first and foremost is that on the outer side, we can also connect to a legacy machine, for example, over here, to the signal tower light. And then from the signal tower light through a gateway, of course, sensors, or even connect to it, we are able to get the information like run, stop, pause, standby, alarm, emergency, disconnect. All this information, when you collect it, you are able to know the machine utilization today, right? So simple as that. So then, if you want to do AI, so more areas needs to be done, because you need to have to know the health of the system. So with that, we add on wired sensors on the external of the X motor, or even Y motor or Z motor over there, external that wired into the gateway. So it collects data in terms of the temperature, in terms of the vibration and sometimes sound as well. And others we have not done yet is to connect to the digital power meters to see the input of the power regulation. And another areas that we did on a slightly newer machine is to connect to the controller itself, like for example, the FANUC controller using the forecast protocol. And from there, much more information that we are able to get without we are able to get compared to from external sensors. So from there, we're able to get the servo motor, the overload, what is the RPM on the spindle, the feed rate, how fast is it, and also the feed rate override. What are the tools that's being used on the machine? How frequent is it? And also the coordination, and also as well as the program with it. Apart from that, if let's say you embark on a journey of AI, that's what we are doing. We also add on wireless sensors that we put inside the machine, and then so that we want to do, our mission is to predict when will the tools be broken while machining. This is what we want to prevent. We want to prevent from the tools being broken so that we are able to prevent things like a tool broken inside a part or even abnormal machining of the parts, right? Or of the item. So this is what we did, the experiment. So from there, first and foremost, we go back to the drawing board, understand with the subject matter experts in terms of the CNC machining tool immature breakdown. What are the causes, the 6 causes that can happen to this tool breakdown? Okay, this time I'm not going to deal deeper. And with that as well, you also need to have the digital maintenance, whereby if the tool breaks, at which number breaks, why is it break? So the person will take a phone, snapshot, put the tool ID, the issue, when is it occurred, of course, and a picture of tool. All this goes back to the database, because then you are collecting the data. Why is it broken, right? Then from the controller itself, you also run what is the current tool that's running, how much time is running, and the next level we are doing right now is that how far is it running. So the predictive result that we are achieving is that if all the tools are green, it means that all the tools are okay. However, if one of the tools shows a red or amber, we will need to alert the on-site technician or engineer to stop or check the tool so that things can to prevent things from broken inside. For example, if let's say the triggering trends are a lot higher in terms of sound or even vibration, and this shows that it's an amber alert. So it tells you that please check tool ID number 7 because abnormality trend detected. It's all about the trend. And then if it's a red, it tells you about the tool ID 13, tool failure predicted. Of course, we are still defining a lot inside the algorithms as well, make it easier to predict tools at the when is it failure within a day or even within hours. So this takes a lot more data to do, a lot more experiments, a lot more failure. However, we don't say failure, however, areas we know that doesn't work, right? So all this requires a lot of experiment as well, or even POC. Other than that, we also put in, like for example, unsupervised learning to have an IP camera so that you can know what is happening on the machine. Other than that, we are also optional to do is to put in an IR camera, especially if you are talking about parts, huge parts. It could be automotive or it could be aerospace. That thermal expansion is very important. So depending on the parts, so this becomes an optional. So what I shared just now is preventive to predictive, especially taking into machines and what are the areas that you can use it and a use model that for your application. Next, I'm going to talk about predictive to prescriptive. So this is the one of the next level that we are embarking upon, but you need of course all the previous information that especially on data collection. Okay, so I shared about Proact over here in terms of AI, in terms of machine learning, going towards analytics and also the digitalization. So while we go towards the journey of digital twin, this is the area whereby disruptive model will come in. So if you're able to come up with some of the models, you can sort of convert your current business model into disruptive business model compared to your competitors. And this is where the next advance will come in. Okay, so what we are doing over here is that there's a lot of areas combining towards digital twin. First, you must have of course, the data for cloud storage, IoT, edge, and AI. Then you're able to go towards that. Very important, the data model, the connecting, getting the data, analytics from the AI, and of course, the last but not least, the human knowledge. The knowledge from the experts, the knowledge from the subject matter experts is so important moving towards that. Okay, so what we are doing is that because Vitrex is in the providing the machines mainly for the electronics industry, we are coming towards a process insight, because process is very important, and towards describing what are the quality. From there, we have to do areas of combining different inspections within the line so that it can give a prescriptive model. What are the things that needs to change in the front of the line, so that we're able to do prediction and changing certain parameters so that the outcome, especially the yield, can go up. So this is where we are going towards, and it needs a lot of experiment. That's why because Vitrex, we also purchased one SMT line to do a lot of this experiment, as well as to do data collection as well. So coming soon in 2023, however, in order to do that, these are so many things that we need to do so that to make sure that a lot of data can be collected, connected, and then make sense. It's more important. Okay, so last but not least, the last 5 minutes, I'll share with you the lessons learned, and of course still learning, and then a little bit more on the partnership with SHRDC. If you have any questions, please put it on the chat box. Okay, I'm going to share about 3 points. First, each step has its difficulty level, but KISS. What is that? So every step, as I shared with you, the connect, visualize, even proact, has its difficulty. Some companies we've helped them to do connection, finding the right sensors, finding the right process, finding the right tools, the right protocol to connect and collect the data. It is also difficult. And then when it comes to visualization, okay, what is the best charts? What's the best combination of charts that makes sense towards the engineer, the technician, the manager, or the boss? So different people will want different things. And then, of course, if it comes to AI, which machine learning model is the best? Is it accurate enough? Is it fast enough? Is it a combination of different algorithms? So all these things require efforts. And sometimes if we go to proact, like what we did, we found out that the information are not enough. So we have to go back to the connect, get more sensors, different types of sensors, connect to it to collect more data, make sense of it, then go back to AI again and run again. So all this back and forth will happen. But most important is keep it simple, keep it short and simple. Because if there are things that can be done, especially in preventive maintenance, then that's the best. You don't have to go to predictive just because the marketing wants it or for the glory of it. But if you're able to get it, keep it simple, make it short, and if you're able to go towards preventive and then solve most of the problem, that will also suffice. Okay. If cannot, then of course you go to the next one. Then the second lessons, collaboration from at least AI programmer, IoT engineer, and subject matter experts. In these 2 years of COVID, whereby we use so much of Zoom, so much of Google Meet, our meeting calendar is like all back to back. Sometimes some of us even have to attend 2 Zoom at the same time, or 1 Google Meet and 1 Zoom. That's what I did. So in the past, we had to go to the customer, understand the customer's problem, then go back to the engineer, and then figure out and then discuss and go back again, back and forth traveling. So a lot of times it's taken a long time. But with this teleconference, it is now easier whereby AI programmer, IoT engineer, and subject matter experts sit together in a conference room, in a webinar or in a Zoom meeting to discuss a lot of issues. not many companies would have an AI programmer because AI programmer is expensive and it's not easy to keep. However, what we did over here is to make it an IoT engineer and even a subject matter expert like me are able to use simple machine learning. So that is what we are aspiring to be. And that's what we are wanting to make it simple so that a 45-year-old blue-collar worker or a TVET graduate is able to use machine learning. And from there, of course, if he is able to expand further and then move into deep learning and many other customized program if he has the interest. So getting the results and getting the subject creates the interest towards moving towards AI. Last but not least, be daring to make mistakes, but learn, because in this journey we make a lot of mistakes. We buy certain things that that we thought that it gets data. However, data just doesn't come in. It doesn't make sense. And then certain things that doesn't make sense, we try an error, and we come, voila, things work. Because then we celebrate even small wins. And then important, go back to the drawing board, recalibrate with the subject matter expert, because sometimes an AI programmer will want to do a lot of very, very difficult things. However, the subject matter expert sometimes will ask, like, for example, I will ask a question, does this make sense? Will it become too expensive? Will the engineer or the technicians who are the user of this machine find it too difficult? Because sometimes the engineer or the user just wanted something simple. Okay. Last but not least, of course, Vitrex and SHRDC is always in partnership, and we started a journey and this year, middle of this year, whereby we have collaborate using their one of the connect programs in Node-RED to connecting to PLCs, connecting to machines, and then from there we able to share out and learn together. And this is one of the areas of upskilling our TVETs and also upskilling our staff and also our people, right? I also learned it over here as well on Node-RED. And of course, we will provide the certificate of participation after you finish your course. Okay, and just a little bit of advertisement. Next week, we will have a virtual instructor for beginners class for V1. So our IoT engineer and also AI trainer will also provide a crash course. So you can register on this QR code or this link over here, webinar.speaker.-October-2021. Take a picture, take a snapshot, and you can register for free. Okay, you can learn over there, and you can also ask your staff to learn as well. But because, for example, me as a non-programmer, I can do a simple workflow, simple machine learning. I'm sure you or even your staff can do that, right? Last and not least, we're always with you. We're in Penang, even with the Zoom, even if you, let's say, overseas, it's so short right now. I mean, it's just only one call away, right? And we have put in so much effort, almost 5 years, 6 years of effort of R&D within for our products program, and we will assist you in your journey towards Industry 4.0. Last but not least, in the era of Industry 4.0, digital transformation, of course, can begin with you. So if you want to go to this our website, we have a lot of webinars that we have done before. You can continue to learn from there. Of course, give us a comment. And if you want some testimonies, some sharing, go to YouTube, click in, type in Vitrex space V1, and then there's a lot of testimonies as well as some sharings that we put on YouTube. With that, I can be contacted on my contacts below, or even make an appointment, virtual appointment with me on this, and then we can help you in your understanding your manufacturing issues. Okay, if there's last but not least any questions, so you can put in the chat box. And that's all for my presentation today. Thank you very much and it's my honor.